Can you do functional programming in any language? Is it possible to do functional programming in C, in Java, in assembly, in Ruby? Or do you need a functional language? And what is a functional language anyway? Well, my name is Eric Normand, and these are my thoughts on functional programming. So, the short answer is yes. You can do functional programming in any language. Functional programming is a paradigm. It's all in your mind. It's how you break down problems. It's how you see things. It's how you think about the problem and how you structure solutions. If you're thinking about the thing in terms of actions, calculations, and data, then yes, you can do functional programming in any language. Just like you can do object-oriented programming in any language. So object-oriented programming is also a mindset, it's a paradigm, and you could figure out how to make an object system with messages passing around in C. And in fact, I've done that before. What I found though, and what I think a lot of people find when they do something like that, when they create like a little object-oriented system in a language like C, is that so much relies on the discipline of the programmer, because you could always slip out of that object-oriented programming. You know, you can sneak behind the nice veneer you've put on and just mess with pointers and do all the C stuff that C allows you to do. And if you're doing functional programming in C, you would have all of those same possibilities, and they would tempt you. But people who are really good at functional programming, who are used to it, who are well versed in how to solve problems with it, they tend to, and they like functional programming too, and they're choosing to do functional programming, they're going to have a better time because they're choosing to use functional programming. It is a choice that they are imposing on the language, on the program that they're writing. And even if the language doesn't provide something, they will maybe write it themselves. And so they have this discipline that is what allows them to do functional programming even when the language is not really helping them. And so that's my short answer. My short answer is yes. You can do functional programming in any language. But the long answer is you probably don't want to. So one reason is that relying on discipline might work in the small. If you're writing a small program or you're writing a program by yourself or on a very small team, you can handle the discipline of it. Right? You can handle the copy on write discipline or the append only semantics, right? Or the lack of any help figuring out what is an action and what is a computation. It's all discipline. You have to know this thing is an action. I shouldn't call it from a computation, from a calculation. So the other thing, the other part of the question is, if you're going to, yes, you can do functional programming in let's say JavaScript, but if you don't know functional programming, you're not going to learn it in JavaScript. It's like trying to learn to speak a natural language, like trying to learn, like let's say you don't speak Spanish, and you're going to try to learn Spanish, and you're going to try to learn Spanish just from people who also don't speak Spanish, and maybe just from a book, and you have no help, and sure, you can do it with like tons of willpower, or you could get on a plane, you can fly to a Hispanic country, a country that speaks only Spanish, and you can start, picking up this and that, and you have people to ask for help, and all the signs are in Spanish, and it's just immersion in Spanish. You're gonna pick it up. You're gonna feel like this need to learn it, right? Even if you still learn it from a book, there's a lot of stuff pushing you in that direction. And so that's been my experience with functional programming in other languages, that you can do it, but if you don't already know functional programming, you're gonna feel like it's not right, or you're not gonna learn it. You're never gonna get over that hump, because you can always just revert back to whatever the language is and whatever is natural for that language. And so that's what I find, is people who say like, oh, I know functional programming, I'm learning functional programming and I've heard I can do it in JavaScript. You're gonna learn like this much functional programming and not really get the meat of it. There's a lot of people who, it's all cool, but they don't get very deep into functional programming. And that's cool, if that's how deep they want to go, but there's deeper stuff that they're gonna miss, because they're not forced to find functional solutions by their language. Just like you can learn to say gracias and that kind of thing just from picking it up, but you're not going to learn it. You're not going to learn all of Spanish doing that, even conversational Spanish. So, yes, you can do functional programming in any language, but it's going to take discipline. You're not going to be able to learn functional programming. And 3 is it's going to be a pain. That discipline could be a real pain. It could feel unnatural. It could feel like it doesn't really work in that language, and that it could feel like it's not the language's fault, it's functional programming's fault. Like functional programming is totally impractical. It could feel like that. And so I don't recommend people try, if they're not already well versed in functional programming, I do not recommend they try doing something like functional Java, functional JavaScript as like an introduction to functional programming. Because it's going to feel like why am I jumping through all these hoops? Why am I copying everything? Why can't I just modify this variable? Like, it doesn't make sense. Because they're right. Like, my language is letting me do that. It's the simplest solution. Why should I do this other thing? And of course, the answer is until you do all functional programming everywhere, immutable everywhere, you don't realize the benefits. So, then that brings us to what is a functional language. Now, of course, there's it's one of those controversial topics where You can say there's no real answer, that anytime someone actually tries to define it, they're missing stuff, and so then it opens up the doors for argumentation and flame wars. So I don't want to go there and say, like, here's the definitive answer. Here's the definitive way of defining what a functional programming language is, what it takes to be a functional language. I actually don't think it's that meaningful. But when I use the term, what I mean is a language that helps you do functional programming. A language that helps you do functional programming in whatever way that the language chooses. So in Haskell, it helps you do functional programming because everything is immutable by default. You have functions which are pure, and so you can do calculations, and you have an IO type for doing your actions. And it helps you, the language helps you, the type system helps you by separating those things out, the calculations from the actions. Now, I also think that Clojure is a good functional language, or is a functional language, and it's functional because it has immutable data structures by default, and it doesn't help you separate out the calculations from the actions very much, but it does encourage you to separate them out. And they have been separated out in much of, like, the core library, for instance. And it also helps you do that kind of, the stuff I've talked about before, about reasoning, about the actions, collapsing the states of the actions into a smaller set so that things become more manageable. And so, because it does all that, I say that it's a functional language. Now, JavaScript has functions, has higher order functions, but it doesn't have the immutable data structures, and it doesn't encourage immutability in any way. So it's much less so. So if you want, you can call it a continuum, but it also encourages this other style where you're using mutable objects and have these methods, and now it has the class syntax. So it's actually not so functional when you look at it as a whole. There is a nice functional subset in there, which would make it really nice for doing functional programming if you could restrict everything to that subset. I would say that that's a pretty good functional language. It's a mutable functional language, but you can work around that with a little discipline. So anyway, that's how I think about it. That it's a spectrum, and then I think language subsetting is an interesting idea. Like JavaScript, it's this thing that everyone in the world is going to use, but you can find a little slice of JavaScript that works for you, and you can set up some linters and have a reasonable functional language there. Hope it's not too windy in the microphone. It's pretty windy from my perspective. All right. So there's something I do want. This is like for those of you who have stayed to the end, you have something special. There's something I want to say that's related to this immersion in a functional language to help you learn functional programming. I worked in Haskell for over 2 years. More like almost 3. But what I mean is I was immersed in Haskell. I was immersed in a language that was definitely functional. that there was almost no other style possible in Haskell. And I had already like done a lot of closure on the side in my own projects and used it at in small things at jobs and stuff that wasn't going to go into production. And Haskell, an immersion in Haskell really taught me to appreciate the separation between calculations and actions, and just in a way that I find that a lot of closure programmers don't appreciate. That the immersion in it, and the type discipline too, the type discipline of, this is probably a topic for another episode, but just like in actions where sort of anything is possible, really, so you want to restrict that, you want to collapse down the possible states into a fewer number. So if you have something where the order matters, maybe you can make the order not matter. And so now the two states where you have A comes first or B comes first, now you can make it doesn't matter, it's the same, you get the same answer. You collapse the two states down into one state, right? Just in that same way, I feel like the type discipline that Haskell's type inference engine enforces collapses states. So a closure programmer might say, I'm going to return a number or a string or nil. Well, that's really three possible states, and you're going to have to check those later, whatever consumes that return value. You're going to have to. You're going to have to check, you're going to have to branch, you're going to have to do something based on what you got there. Whereas in Haskell, you can only return one thing. Or if you do want to return multiple different things, you have to be very explicit and encode that in a type. And so you're making that choice. This is important enough. I'm going to use all these cases later, and so I'm going to make a type for this. But in Clojure, we're much more loosey-goosey, and we don't. That opens up the possible states, and states are multiplicative. They compose by multiplying each other. All right, so that's going to be another episode. So stay tuned. Subscribe to the podcast. Subscribe to the YouTube channel. And this has been Eric Normand, and I'll see you later. Bye.